Hello guys, welcome to one more question on System Verilog interview series. So let's start this problem. So in this problem we are given a problem statement on a memory allocation. So let's try to go deep into this problem. So uh, the problem statement title is safe memory region copy memory operations, which means it is something to do related to memory operations. So if we read further, so we are given that you are writing a memory model for a DV scoreboard. The model is a flat associative array byte mem of it. Implement a copy region inside memory model. It copies number of bytes starting at source address into the region starting at destination address. So we need to copy the number of byte or chunk from source address to the destination address in a given memory. So if we see the function, what we need to implement is, let's say you are given a memory, and inside the memory you are just supposed to copy some content of memory from one location to another location. So you, in order to copy the content from one location to another location, you are supposed to implement a function named copy region which does this operation. So even as we can see in this function, there are three arguments, and which means that the first argument is source address, the second is destination address, and the third is number of bytes. Even if we see in these parameters, uh, the source address means the starting address to read from, the destination means, as destination address means the starting address to write to, number of bytes means how many bytes to copy. So let's assume if you have a memory of let's say 10 locations, and source address, let's say if it's 0, and if let's say the destination address is 5 and number of bytes is 2, then what does that mean is you are just supposed to copy two locations from at 0th and 1st position, or the 0th and 1st address of the memory to destination address, that is 5th and 6th location of the memory. So just copy the two locations from 01 to 56, and that's all. But here we need to make, so this is simply you need to do in order to achieve this copy region function, and that we need to write a function here. So our task is only to code this function, and all the other test bench is likely to present is already present in the solution. So the question might sound simple, but there are a lot of corner case to this question if you think deeper. So let's study this question in a more animated way. So I have one more animation for you, in which we would be visualizing how the memories would be getting updated once you copy. So let's take some examples in order to understand this problem more. So in the let's start with the simplest example. So as we discussed that our task is just to copy memory data from one location to another location. So SRC, you can treat SRC as source address, DST means destination address. So here we are just trying to visually understand how the copy data would be working. So let's say if the source address is 0, the destination address, if let's say I had given 10, and let's assume that the number of bytes, there was also a third argument named as number of byte, which let's assume as 4. So in that case you would be having four source locations, that is 0, 1, 2, 3. Destination address would also be 4, that is 10, 11, 12, 13, and you are just supposed to copy data of data from 0 to 3 to 10 to 13. So here we are trying to have a visual representation of a memory, how it would actually look like. So you can just assume this to be as a memory, and this 0, 1, 2, 3 actually represents the addresses. So this 0 is this one, and 0, 1, 2, 3, and the destination here, as we can see the color code as well. The source has been colored as blue, the destination has been colored as green, and if there is overlap region, then it is covered as orange. But yeah, so in this question, the first four locations is been marked as source, which means that we need to copy that to the destination, which is marked in green. So let's assume the data in 0, 1, 2, 3 would be A0, A1, A2, A3. This is just a random data that we are assuming. It could be any data like 5500 FF, anything. Just we had assumed it to be A0, A1, A2, A3 for easy understanding. So here also you can see that source region blue, address 0, 2, 3 holds A0, A1, A2, A3 data. So after the copy method, the A0, A1, A2, A3 should eventually be copied in this green region. So if I can show you with this animation, then it should look something like this. Uh, the A0, A1, A2, A3 now actually got copied into this A0, A1, A2, A3. So your memory data should something look like this after the operation is completed. So this is one of the basic scenario that we are taking. Now let's take some more advanced scenario. So let's now take the source address value as 0 to 4. The same, we have just added one more value in the source address. That is, let's take the source address as 0 to 4 and destination is 0, 2 to 6. Like what does this mean is the source starting address would be 0, the destination starting address would be 2, and the number of bytes here would be 5. So that's why here we are showing that 0 to 4, meaning total 5 unique digits are there. So number of bytes you can treat here as 5, and here your idea is to copy the data from 0 to 4 to 2 to 6. Similarly, as we saw in the first question, we copied from 0 to 3 to 10 to 13, and but in the second we are trying to copy from 0 to 6 to 0 to 4 to 2 to 6. So let's try to visualize with the help of this diagram. So the blue here represents the source. The color coding remains the same across all the test cases that we are discussing. So here the blue is source, green is destination, and overlap is shown in the orange. So here, let's say first we are color coding the source. So 0, 1, 2, 3 are the source, 2 to 6 are the destination. So 2, 3, 4, 5, 6 are the destination, and here the reason because this 2, 3, and 4 are marked as overlap region is because it is common in both, that is source and destination. So now your task is to copy the value from source 0, 1, 2, 3 to the destination 0, 1, 2, 3, 4 to the destination, that is 2, 3, 4, 5, 6, right? So now just think that, let's say if you start copying as we done in the previous test case, like in the no overlap case. Let's say if you just directly copy the value of 0 to 2, then you copy the value of 1, 2, 3, then it would be like you copied the value of 1, 2, 3. Now let's say if you copy the value of this B2 to 5, and the fourth and the yeah, and the third copy would be B3 would be copied to I think okay, I think we are going somewhat wrong here. Okay, let's try to again think this. So here the first would be the B0 is the first location, so B0 would be copied to 2. It's that is this location. The B1 would be copied to B3. this again. Okay, so here's the catch. So the let's think that the 2 3, here we are supposed to copy the value from 0 to 4, right? All the locations, all the way till here. So let's say if you copy the value of 0th address to the second address, what does that mean is the second address is now overwritten. So let's say you copied the value of 0 to 2, 0th to second location, you copied 1 to the third location. Now you need to copy the value of 2 to the fifth location, but the value of 2 eventually holds the value of 0. So what does that mean is you are eventually overriding the value, original value at the second location what was initially stored inside this memory. So as a result, the value gets overridden. So the B0 would be having the bit at the B0, this B0 value should eventually be stored at this location, and the B2 gets overridden. Ideally, this B2 should not be overridden. So and because let's say if you do in this way only, then the b2 will eventually get copied to fifth location, which is would be a wrong data that we will be storing inside fifth as well. So we need to come up with some another solution in order to do this. So even let's try to simulate this case as well. Alright, so as you can see here, let's say initially the values was like B0, B1, and some B3, B4, and B5. So here, after copying, what it will do is the B0, B1 will be copied here, and this B0, B1 would again be copied here at 4 and 5. And the sixth value, which means that this one would uh, eventually be with this value at fourth location. So as this is a corrupted data, and which means that forward copy overwrote source byte before reading them. And here, as you can see, the tool also says that forward copy corrupts data when destination address is greater than source and region overlaps. So this is a condition where we have a overlapping region, that is 2, 3, and 4. So let's try to fix this problem. So in order to fix this problem, what we can do is, so let's say the source address is again the 0 to 4 and destination is 2 to 6. So now instead of copying from the first value of source to destination, we can go reverse. What does that mean is, instead of first copying value of B0, instead of first copying the value of 0th location to second location, we can first copy the value of 6th location to the 4th location. So if I can explain you here instead of copying the value from 0 to 2, we will be first copying the value of 6 to 4. So here the sixth value, sorry, I mean here we will be, I think we just got reversed. Here we will be just copying the value of 4 to 6. So what does that mean is, first let's say this all are the original data B0, B1, B2, B3, B4. So B4 would be copied to the sixth location, then B3 would be copied to fifth location, then B2 would be copied to fourth location, B1 will be copied to third location, B0 would be copied to second location. So if you see in this way, we won't be corrupting the data, or we won't be overriding the original data, right? So all the destination, that is 2 to 6, would actually be updated. So if I can show you via some animation. So see, after copying, what it did is your 2 to 6 now holds the value B0, B1, B2, B3, and B4, right? So our idea is that the destination should always get the correct value. So in this way, it is also satisfied. So just we need to make sure that if and only if the region overlaps, then we need to do reverse copying instead of forward copying. So here we found one condition what we can change, and let's try to see some another test cases. Let's say this is one more test cases named, which is kind of same as before. The only difference here is the source address is greater than destination address. So here the source address starts from 4 and the destination address starts from 2. So this is unlike the previous test cases where the source address was actually less, was having less value than the destination address. And so this is a different scenario that we are discussing, which means that the source address, that is 4, is actually having greater value than the destination address. So let's see in this test case how the memory copying would be done. So let's say this is, so let's assume that our idea is to copy the 4567 to 2345, right? So let's first think what will happen if we do forward copied forward copied in this case. So let's say first you have this 4, it should be copied to sec 2, the 5, the address 5, the data C5 should be copied to third location, the C6 should be copied to C4 location, the C7 should be copied to C fifth location. So it seems that in this test cases, the data won't be corrupted or overridden, and we can also confirm this from the simulations. So I think in this case, the C4, C5, C6, C7 should actually be like after copying, it should be like C4, C5, C5 in the third, then C6 and C7, and this both will still hold C6 and C7. So let's try to simulate this. Alright, so as we discussed, here after copying, it would, the 225 will again hold C4, C5, C6 and C7, and this anyway will be holding the older data. So which means that we got two scenarios for overlaps, because in this also there was overlap region happening. The fourth and the fifth region was actually overlapping, but here we are not supposed to do backward copy. Here we need to only do forward copying, because let's say here if you do backward copying in the memory, then the data would actually got corrupted, because let's say in this overlap, if you had done backward copying as we discussed in the previous test case. So here let's say if C4, C5, C6, C7, instead of first copying C4, if you had copied C7 to fifth location, and that is this location, then what does that mean is the data of fifth location, that is C5, is actually overridden or corrupted, and it will hold, and it will, the original data C5 would be lost, and our idea is that the C5 should also be copied to the second location. So in this case you are only supposed to do forward copying. So if we summarize all the test cases or all the things that we discussed in one slide, then it would be something like this. So our idea is to implement a copy region function inside the code. The function should first detect that whether there is a overlapping region or not, depending upon the values of source address and destination address. Let's say if the value, if there is a overlapping region, then there are two possible scenarios as we discussed. So the first test case was of no overlapping. The second, third and fourth test case are for overlapping regions. The in the overlapping regions we have two scenarios, one is backward copying and one is forward copying. So let's say if you have destination address greater than source address, then you would be doing backward copying. And if you have if you have source address greater than destination address, then you will be doing forward copying. So as we can see here, first detect the overlap. You can write your any piece of logic to detect the overlap region, how you can detect it. Then once you detect the overlap region, then you need to see whether the source address is whether the destination address is greater than source address or not, right? So if let's say the destination address is actually greater than source address, as we discussed in this scenario, let's say 2 is greater than 0, then in that case you read high bytes first before destination overrides. And let's say here is the opposite case. If the destination address is lesser than source address, then just copy do the normal forward copying. And let's say if there is no overlap condition, then it's very easy to copy. You just copy the data from one location to another with the help of forward copying. So if I can think of the like in summarizing this test cases, then there are actually three test cases possible. There are three ways to write the of this function. One condition is a normal no overlap. You just need to copy a thing or data from one address to another. Second is overlap, which would have two conditions. One is forward, one is backward. Backward will only occur when destination is greater than source, and the forward will only occur when the source is greater than destination. And depending upon that, you just are supposed to copy the methods. So even if I simulate this, okay, all right. So this is just a final way in which how you can write the logic, but it depends upon you in, in which way you want to write. This may be one of the way of writing this. So, and by the way, there is one more scenario that could be possible. Is let's say if you are writing source address and destination address value as exact same value, then in that case ideally the data should be restored. Let's say if you are writing source address, if you are giving source address as 5, you are giving destination address as 5, and number of bytes as let's say 1 2 3 or any value, then in that case you're just copying the value from same memory address to same memory address. So in that case the original data should remain same. That's why here it is written that mem x and mem x, it's no operation. So ideally it should not do anything. Whatever is the data, it should retain that data. So this is the test cases that you need to make sure that you write in your code. And so here, as we can see in the code, so I think now after discussing all these test cases in such detail, it would be very easy for you to write this piece of logic. Like here, what you can think of, like it would be just 3 to 4 scenarios that we discussed, and you are just supposed to code here. I am not writing the code here because after I think discussing all these test cases in detail, you can easily write the code here as per your logic. And here we are already given all the test cases that we discussed, like no overlap, overlap. Fourth is with the same address. The test 4 is the same address. So once you are done with the logic, you can directly verify your logic whether with our test cases whether it is correct or not. So alright, I hope this problem helps you to understand how the memory copying works and how you can come up with all the corner cases in even such a simple problem. So let's give it a try. You can try this code implementing yourself here, and please let us know in discussion section if you face any issue or if you have any trouble solving this.